Today we're going to get into dividing polynomials. So this will help us find solutions of polynomials, and solutions are going to be zeros, which is where they cross the x-axis if they were graphed. So we're going to have to be able to divide kind of like we did in, back in elementary school with the old long division. We're going to do that today with polynomials. That is one way that you can divide polynomials. Answer format, we'll get there. We'll see. So this is a problem that you may have seen way back in the day. Now you probably were just dividing by 2 back in the day, but here we're dividing by 21. So you would write the 21 here, and then the number you're dividing, 675, goes in here. So you check and you're like, how many 21s can go into 6? 0. So then you bring in the next digit and you're like, how many 21s can go into 67? You're like, well, thinking of 2 and 6, you're like, 2 times 3 is 6. So you'd be like, probably 3. So you write a 3 up here. And then remember, you did 3 times 21, which is 63. You wrote it down here and you subtracted it. So what I want you to think of is like, always bring it down as its opposite. That would be like subtracting, right? So it would be positive 63, but we're bringing it down as its opposite, negative 63. 67 minus the 63 would be 4. Great. Then you bring down your next digit, and now we're looking at 45. How many 21s can go into 45? And you're like, 2. So you'd write the 2 up here. 2 times 21 is 42. You would subtract it, but again, I want you to start thinking of it this way. Bring it down as its opposite. So 42, the opposite, negative 42. Boom. 45 minus 42 is 3. So in 4th grade, if it didn't divide out evenly, you might say 32 remainder 3. Not anymore. We're going to take that remainder. We're going to make it a fraction. That's going to be the numerator. The denominator is going to be whatever you were dividing by. We were dividing by 21 here. So it's 32 and 3 21sts. However, you got to simplify it if you can. 3 21sts, 3 goes into both of those. It goes into 3 one time. It goes into 21 7 times. So we'd have 32 and 1/7. That's old division. Now we're going to divide some polynomials. Now here we're dividing by 2x plus 1. So I'm going to put the 2x plus 1 over here. And I'm going to write 6x squared plus 7x plus 2 over here. Now it is important, if you are missing one of the degrees, like if that started off 6x to the 3rd, and then the next term was x to the 1st, you would want to put a place filler for the x to the 2nds. And I'll show you that'll happen later. But this one, we don't need anything. We have 6x to the 2nd, so that's the 2nd degree. We have 7x to the 1st, that's the 1st degree. And then we have 2, that's the 0 degree, that's a constant. Cool. So we're checking 2x into 6x squared. 2x times what gives you 6x squared? And that's 2x times 3x. Or you could be thinking of it like 6x squared divided by 2x. And that would give you 3x as well. That works. Cool. So I write the 3x up here. I'm going to multiply the 3x times each of these terms out here. And I'm going to bring it down as its opposite, because we're going to subtract it, right? So 2x times 3x is 6x squared. I'm bringing it down as its opposite, negative 6x squared. I also have to do 3x times 1 is 3x. Bring it down as its opposite, negative 3x. So here 6x squared minus 6x squared is nothing, 0. 7x minus 3x is 4x. And then we would bring down our next term, the 2, 4x plus 2. And now I'm saying 2x times what gives me 4x? And that's 2x times 2. So we'll put plus 2 up here. We're going to multiply it by each term, write it down as its opposite. 2 times 2x is 4x, negative 4x. 2 times 1 is 2, negative 2. Look at all this stuff zeroes out. That's great. It divided evenly. There's no remainder. So that would be our final answer, 3x plus 2. Unbelievable, right? That was fun. Example 3. We're dividing by x minus 2. So I'm going to write x minus 2 on the outside. Now, there's a little trickery at play here. 4x squared plus 3x to the third. You got to write it in standard form. So I should write 3x to the third first. Then plus 4x squared. Now, there are no x to the first powers. You got to put a place filler there. So we're going to say plus 0x and then plus 10. Otherwise, everything at the back half is going to be off. You got to put place fillers when you're doing division. I have x. I need it to be 3x to the third. So x times what gives us that? Well, x times 3x to the second would be 3x to the third. Oh, shoot, I just wrote the same thing. Oh my gosh. Oh my gosh, you can't take me anywhere. 3x to the second. All right, so we'll multiply it by each term and we'll bring it down as its opposite. 3x squared times x is 3x to the third, negative 3x to the third. 3x squared times negative 2 is negative 6x squared. Bring it as its opposite, positive 6x squared. Whoa. So these will cancel. 4x squared plus 6x squared is 10x squared. And then we'll bring down our next thing, plus 0x. Cool. X goes into 10x squared. That's x times 10x. So we'll put plus 10x here. 10x times x, 10x squared. Bring it as its opposite, negative 10x squared. 10x times negative 2 is negative 20x. Bring it down as its opposite, plus 20x. X squared's gone. 0x plus 20x is 20x. And then we'll bring down our next digit, plus 10. X, I need it to be 20x. That's x times 20. 20 times x, 20x. We'll bring it down as the opposite, negative 20x. 20 times negative 2 is negative 40. Bring it down as positive 40. X's cancel, we're left with 50. Now, x does not go into 50. So this is like our remainder. But again, we're not writing remainder 50. Here's how we write the remainder. We're going to say plus whatever we got left over, 50, over whatever we were dividing by. We were dividing by x minus 2. So we're going to say plus 50 over x minus 2. That's how we're going to write our remainders in this unit. Now, if that was negative 50, you could say plus negative 50 over x minus 2, or you could make it minus 50 over x minus 2. Either way. All right, number 4. We're dividing by x squared plus 3. I don't need any place fillers because I have to the fourth, third, second, first, and then 0. So 1x to the fourth, minus 3x to the third, minus 4x to the second, minus 1x plus 8. That looks a little wild up there. All right, cool. I have x squared. I need it to be x to the fourth. So that would be times another x squared. X squared times x squared, x to the fourth, bring it down as its opposite. X squared times 3 is 3x squared, bring it down as its opposite, negative 3x squared. Now here's the trickery. We just went from x to the fourth, now we have x squareds. It's going to be tempting to just write it right next to it because that's what we've been doing. But we're going to put the x squareds with the other x squareds. Now the reason there's going to be a gap in each line here is because if you look what we were dividing by, it was x to the second, which is the second degree, plus 3, which is the 0th degree. So it skipped the first degree. So there's going to be a hole in every line on this problem. X to the fourth minus x to the fourth, gone. We'll bring down our negative 3x to the third. This will give us negative 7x to the second. And I'll be honest, there's going to be a hole on this one. So we're going to also bring down the minus x. Which, if you wanted, you could bring down everything every single time if you want. It's just, usually we were only messing with the first 2 terms. That's why we only had 2 terms on each line. But, whatever. All right, we have x squared. I need it to be negative 3x to the third. So again, we're doing negative 3x to the third divided by x squared, or we're thinking in our head x squared times what gives us negative 3x to the third. So that would be negative 3x. Negative 3x times x squared, negative 3x to the third, bring it as positive 3x to the third. Negative 3x times 3 is negative 9x, positive 9x. X to the third's gone. We'll bring down our negative 7x squared. Negative 1x plus 9x is 8x. And we're also going to bring down this plus 8 back here. All right, okay. I have x squared. I need it to be negative 7x squared. Well, duh, times negative 7. That would give me negative 7x squared. I bring it down as its opposite, positive 7x squared. Negative 7 times 3 is negative 21, positive 21. X squared's out. We'll bring down our 8x, and then 8 plus 21 is 29. X squared does not go into 8x, so all of this is our remainder. So remember, how we write the remainder is plus whatever we got down here, 8x plus 29, divided by whatever we were dividing by, x squared plus 3. This would be our final answer. That was tough. Now I have 2 for you to try here. Highly recommend that you actually try them, pause the video, and then I'm going to start just working on them up here and see, if yours match up with what I got here. All right, let's see here. Ooh, little trickery. Little bit of trickery with the, we're going to have 2x to the third. We got the 4x squared. We have 0 regular x's. You better put a place filler there. Then we have our minus 5. Over here, let's see, x squared plus 5, x to the third plus 8x to the second minus 3x plus 16. All right. 2x squared. 6. Okay, x times negative 2x, negative 6x, positive 6x. 6. 6 times 3 is 18, negative 18. So again, you could write it as plus negative 23 over x plus 3, or you could just make it minus 23 over x plus 3. All right, x squared times x. Okay, plus 8. Minus 40. That's just sloppy. All right, here again is a little bit of trickery. On this one, you could write plus negative 8x minus 24 over x squared plus 5. Or, if you want to make it minus, you'd have to make it minus, and then you're going to change both of those. So it would be like 8x plus 24 over x squared plus 5. So that is a little tricky. Maybe you're better off just always writing plus and then negative whatever. But that would be your final answer on the second you try problem.